Welcome back everyone to another video, and in this video we'll be going a little bit more deeper in functions. So previously we have discussed about functions and we stopped in, I guess, about arguments. We are talking about arguments. So we'll be going a little bit more deeper. So the first thing that we'll be discussing is returning values. Okay. So up till now what we have done is um, we have created a function, like we have defined a function using this def keyword, and we wrote some function body, and instead of returning the function we printed, like instead of returning some value we printed some value. Now what is the difference between returning and printing? Now what printing does is it just displays the value or displays anything, whatever you want to display, it just displays it. But returning it, what it literally means, it is returning something. It is returning a value. Now what does returning means? Returning means, suppose you have a function, you have some function definition, your own code logic, and when you give a return something like this, so let's say over here def function, and you have a return statement, and let's say you return x, where x is a variable, something like that. So what this does is it not just shows the value, like displays the value the same as print, it stores the value. So when you call an object, if I call a function object, it will store this value of x inside of this function object1. Okay, and you can now use this whenever and however you want. While in the case of print, you just like got the display or the print of the value. You can't use it at any other point of time. So yeah, that's the basic difference of returning a value and printing a value. And we use the return keyword, and this return keyword serves two purposes, which I've already discussed. First one is you pass the data back to the caller. So the function object that we have created just now, which I've shown right over here, this one, this you are passing the data back to this caller or this object1 right here, and it also terminates the function. Now what does terminate means? Now we have learned about loops, like for loop and while loop, and we have used something called the break statement. Now what break statement does is, when you use the break statement, the subsequent statements are invalid, or it is not, like the Python interpreter doesn't seize those value, it completely ignores, and if you write those values it will obviously throw an error. That's a similar thing for over here as well. So when you use a return statement, it will understand that okay, the function has ended over here and no more statements will be tolerated or appreciated by the interpreter. So it will just terminate the function and it will pass the execution control back to the caller. So what this means is, when you define a function, you can define the function anywhere you want, but you have to call it. Like obviously you can, there is some statement you can define, like suppose you have some statements over here, you can define the function right here, and then you can, sorry, I need to keep up with the indentation. Yeah, so you can define the function up here, you have some function body, you have some other statements, and then you thought of okay, let's create an object of this function. So you can do that. that is up to you, or that is up to the programmer's choice. But yeah, you can do that. So the thing is, whenever you call the function, when you use a return statement, first of all it will terminate the function, like it will end there. It will pass the value back to this object 1, and lastly it will go like the pointer, whatever you can imagine of, it will point to the next statement. Like let's say some other print statement we have over here, it will move to the next statement. That's it, as simple as that. That's it. Now before we move to closures, I guess it's good to have practical of it. So returning in a function, so func1, let's say x equals to 10, return x. So now we can print the function object like this. And first let's do this, then it will be better. So it has printed over here 10. Now I'm saying printed. Okay, actually it should be returned. It's my fault, it should be returned. So if I just say print x, the result or the output will be same. Print x, it will be same. It will show 10 and then it will show none. The reason it is showing none, because there is no return statement. But when you have a return statement, it will not be showing none. So now let's create a function object and let's print vg. Then also again it will show none. But when you use the return statement, then it will not be showing. So let's say func2 2 yeah. So we have done this, and this will be a return statement, and this will be printing a function value. Okay, so now if I run this, we will get 10, none, 10, and there's no none if you see over here. Reason is that we are using the return statement. Okay, yeah. So now let's move on to creating closures. Now what are closures? The thing is, in simple terms, it is nothing but a nested function. As simple as that, it is a nested function. But that is not the whole definition of what a closure is. Okay, so suppose you have two functions over here. Let's say def outer, you have some, let's say x equals to 5, and you have another function inside this function, and what you did is you return x. So let us first go what we are trying to do over here. We defined a function which is called outer. We defined a variable which is x. Now this one over here, it's a global variable. This one over here, sorry, this one is a global function. Okay, so you can access it from wherever portion of your code. So even if you are like like you have created another file. Let's say you're working on main.py and you have created another file called test.py. You can easily use it using import and all. I'm not going to detail right now, but yeah, you if you like defined using the, like if you defined a global function, you can access it from anywhere you want. But this one over here is a local variable. Now the thing about a local variable is it can only be accessed by this outer function. It can't be accessed outside of the code. Also, the thing I want to like emphasize on is in Java and or in some other programming languages, you have this scope, and like you have this public scope, you have this private scope, you have this protected scope. So when you use those in other languages, yeah, you can access your data from anywhere you want using all those access specifiers. But in Python, the thing is you have global and local, these two scopes. You don't have any of this public and private and protected access specifiers, just like other unlike other programming languages. So we have to use this. Okay, so we have this global thing, global function up here, and we have this local variable inside this outer function. Now we define another function inside this outer function, and we call this function as inner. So again, this x and this one are all local to this outer function. And what we did in this function is we return the value of x. Sorry. So we return the value of x. So like we want to know what is the actual value of x. Yeah, no hard issues. We did it. Now there are two cases that can arise. First case is this one is right here. Let's just copy this. And return x. Now if you call this function just like this, you call the function like how we normally do calling a function. If you do this, then it is not a closure, mind you. This is not a closure. Let me write it. Not a closure. So to make sure that it is a closure, you have to return the inner function. So if you have created a nested function and if you return the inner function, so what this does is when you return the inner function, that inner function will remember the data, it can access the data, and it can use it even if the outer function has finished its execution. So you have this outer function which has finished, like you call this, it finished the execution. So obviously you might think like, yeah, it happens about this garbage collection and all. When you call a function and when you have used it, it will obviously go for garbage collection, right? But after the execution, the inner function can still reference or still refer to this variable and fetch its value. Okay, so the inner function closes over the variable it needs from the outer function and keeps them alive for later use. Okay, so if we take an example, it will be better. So suppose I have def outer 1 x equals to, let's say num1 equals to 56, and let's say inner 1, and I'm returning this value. Now instead of calling the function, I'm returning the function. Just like this, you shouldn't like write those parentheses. Yeah, and now object 3 as outer 1. Now if we print this object 3, we should get the function definition. Yeah, so when we printed the object 3, we got the function definition, and now if we call this object 3, like we call this function object, we should get the value 56. Okay, now let's create something which is not a closure. So we copy this, and instead we did this outer 2, and yeah, now we call this outer 2, and instead object 4 right here, and similarly object 4. Now as you can see over here, we are getting an error. Now let's see what is the actual error to get a good understanding. So the thing is, what happened is, let's see, we got this. Okay, let's first comment this lines. Okay, so now let's run this and let's now understand. Okay, so we call this inner 2, and we got none. Okay, let's, what if we return this and then we call this? Yeah, that's fine. Now the thing is, what happened is, if we have just called inner 2, so it just called the function instead of returning the function. Like, wait, let me explain it. When we what we say as calling the function, see, previously when we created the closure, we returned the function instead of calling the return object. Okay, it might be a little bit confusing. Let me show you over here. So what we did is, we have this function definition, we have this 156 return return val1 and return inner. Okay, this is one, and this is another one. Okay, so return again val1, and instead of returning, we are calling. Okay, so what happened is, when we created this function definition, we have this local variable val1 which is assigned the value 56, and we created this inner function which returns the value of val1. Now the difference is at the ending. Over here we just called the inner function. Now the thing is, we are using an IDE instead of Jupyter Notebook or something like that, ideally. So when you use the IDE, the thing is, you get this. When you call the inner function, instead of printing or instead of returning, it will just say what the function, like, the thing is, when you call this, you will get the value none. Reason being that over here in this outer function, you aren't returning anything. Also, you didn't get the value for the same reason, because we are not, like, if we use a print statement, had we used the print statement or the return statement over here, we would get some value. Okay, but since we are not using the return statement for this outer function, see, inner function we have used the return statement. Okay, but for the outer function we haven't used any kind of, like, displaying kind of function. Like, the return keyword or the print function. We haven't used any of those. We have just called the function. So, and also we are in an IDE, an integrated development environment, instead of a Jupyter notebook, which functions like an like what we say as the IDLE, or like which you get by default when you install Python. I've shown this in my very first video, I guess. Yeah. So when we're using Jupyter notebook and all. Okay, the thing is, when you use use this or call this function just like that, without the print statement or without the return keyword, you will get the value none, and you will not able to see your actual value. But when we return this function, the inner function, so it call this inner. So when we uses return keyword, or when instead of return, if you printed, it would be the same. But yeah, we are using return keyword to get the value. That's the main objective. So when we use this return keyword, it points to this function definition, and it will call this function definition. So it will call this function. Then the function has this one, which is return val1. Okay, so it will now return this value, the value of val1. So the value of val1 is 56, so it will return 56. But over here we have this inner function. We have no return statement, we have no print function, nothing. So we are just calling this. So if we just call this, obviously we are just calling this. So instead so instead of returning, like we're not returning or we're not printing, so it will just call the function, and the function will say, okay, return something which is none, because we have no return statement over here. Simple. I hope you get this, because it's quite confusing if you think. That's why I have to give such a hectic explanation. Yeah, and yeah, the last thing over here is when we try to call this object 4 as a function. Now object 4 is not a function at this moment, because it's not a closure. See, the thing is, previously over here we are returning the function. We're not returning the function object, the function calling. Okay, but over here we're returning the function calling, and this function calling is returning the num1, which is 56, and 56 is an integer and not a function. Since it's an integer, not a function, we can get the value, which is 56. But when we call, what is an integer function? You have no definition in Python which says that 56 is a function, or 72, or let's say 45 is a function. You have no definition of such a thing in Python. So Python will obviously throw an error, and the error is int object is not callable. As simple as that. That's why this is not a closure. So let's, yeah, so this is a closure and not a closure function, and this one was the one which gave the error. If error int is not callable. Okay, I hope you get this. Even if you don't get this, you can just write me in the comment. I can make another video for this to explain, because see, understanding is needed to for this, because it's quite confusing as compared to what we have done until now. Okay, so let's move on to the defining and calling functions, some advanced features of them. The first thing is default argument values. So previously we have learned about function arguments and function parameters, and the thing is, when you define a function, suppose we have this function, and let's say you have certain parameters. So obviously when you call this function, you have to give some parameter depending on how you're using the arguments. So if you're using the argument as a string, you have to pass a string. If you're using it as a float, you have to pass a float. If you're using it as an integer, you have to pass an integer. Okay, but what if, like, what if we, like, if we are not passing these values, obviously Python will throw an error. We have seen this in our previous video. Like, if we don't pass a value, Python will throw an error that it is missing some values and you need to pass it. So for that, and there might be cases where we know the value and the user doesn't need to put such values. Okay, for example, let's say uh, let's say, I think a physics numerical would be good. I'm just thinking of a, like, which will be better for you guys to understand. um let's say this quite famous relation of physics, potential energy. Potential energy is for at a particular height. I'm not talking about putting potential energy, I'm talking about gravitational potential energy. And I'm not going into, like, for, like, what we have right now, like all those in-depth, using all those high sci-fi equations, not those. A very simple one. So gravitational potential energy is mgh. Okay, and g is acceleration due to gravity, and we know it's 9.8 meter per second square. Yeah, minus 9.9 whatever. I'm just going for the absolute value of g, 9.8 meter per second square. Okay, now we know the value of g, and let's say we created a function called potential. We need m, we need g, we need h. We have this value, other function definition, and we returned something called the result. And now we created a function object of potential. Do you think it's necessary to pass the value of g, since we know what is the value of g? Right, we know the value of g, so why pass it again? In that case, what we use as, what we call it as, default argument. Like, we know the value of g, so let's use the value of g, and we don't let's say we call this harass the programmer to, like, giving errors, because we all hate errors, but we still, like, our life is full of problems, but without problems the life is meaningless, right? Similarly, the program is always, like, whenever you sit down to create something, there will be errors, there will be problems, but if it's not perfect, like, if there are no errors, then how will I enjoy solving them? I know it might sound a bit cringy, but yeah, that's what I feel. I do feel frustrated, but yeah, there are enjoyments. So yeah, so we have this m, and we can pass g as something like this, and h. So this is a default value. You can pass a string, you can pass an integer, it's up to you. So g is a float in this case, and it is set to 9.8, and we can calculate the result of potential, and we don't need to pass g for this. If we just pass m and h, it's good. But the thing is, it's better to, like, you can still pass the value, like this potential, let's say 20, 10, 20. You can still pass something like this, and it can still work, but it will create confusion, because if you pass 20, it might create error. So the best way is, instead of doing this, you use keyword arguments. You say m is 20, h is 20, and you're good to go. Just run the function. That's default arguments. Next we have variable number of positional arguments. So the thing is, sometimes you want your program, like you want, when you are passing certain parameters to your function, you want it to have as many positional, as many arguments as possible. Like you don't know the actual number of positional argument, or it may be any other like keyword argument, whatever. But the thing is, you don't know. So what you do is, so instead of creating like you create a function, and this is how we create a function, or even like we say a and b and whatever. There's one way that you give a whole bunch of variables, and yeah, that's time consuming. That's one way. Another way is you create something like this. This is what we call as positional arguments, this one. Now it's not, there's no hard and fast rule to use this args or args, whatever we call it as args. So it's, there's no hard and fast rule for you to give this args as the variable. It is a variable. You can give any other variable name of your choice, but it's a convention to use this args as the default argument for positional arguments. So if you use some Python linter, it will throw a warning for it. So now you can use the like you can have any number of parameters for this, because this one is actually a tuple. So the thing will be in parentheses separated by commas. Okay, that's one thing. Another thing is we have keyword arguments. Okay. Another thing is keyword arguments. Similarly, that's the same thing. So you don't want to, like, you don't know the actual number of parameters, sorry, arguments, and one way is to like give a whole bunch of arguments. That's one way. I know it's quite a foolish way if you are doing this, but yeah, that's one way. Another way is you use keyword arguments. Now, what is the difference between a positional argument and a keyword argument? I have said in the previous video, but I'm saying it again. You pass a keyword. Now, keyword can be anything, but yeah, you have to keep in mind that whatever you're passing is a variable. So yeah, and again, the same thing. You can use some other variable name, but it's a convention to use keyword arguments like kwargs as the default variable name, and it is a dictionary. So whatever you pass, the result will be something like this, the value, and like that it will go on. So it's a dictionary, and then you have to like get the keys, as we have done here, as like how we have worked with the dictionary. You have to get the keys and you have to work with it as you feel suitable. Okay, and yeah, you can combine both the position and the keyword arguments. So now you have to keep this in mind. So when you write this code, you have to keep this thing in mind. You can put any number of values, but whenever you're trying to put, like if you put a equals to 2, this is the end, this is the end of position arguments, and this is the start of keyword arguments. You have to keep this in mind. Okay, you can't put another string like this, it will be wrong. Okay, so you have to keep this thing in mind. And for position and keyword arguments, I'm just putting in one function. So define star args star kwargs, and let's print args, and let's print, yeah, just return done. Otherwise it will throw the none value. Okay, so let's do this print fun, and let's go with it. So it has passed this value. Oh, because we haven't passed anything. Yeah, okay, my fault. 4 comma 5 comma 6 comma 7 equals to 2, b equals 6, c equals 45. Yeah, just like this, and you run this. So as you can see over here, 4 5 6 7 and ABC, just like this, and it will show this done. Yeah, so position keyword arguments, we have done this. Next we have, yeah, that's the last one, position only arguments and keyword only arguments. So this was introduced in Python 3.8. Sorry, not Python 3.8, as like it was quite previous, like, yeah. Thing is, I guess it was about 3.5 or 6 that this was there, whatever, but yeah. So this feature is still there in 3.12 as well. This feature is there. So what it's saying is, if you have a function like, and you want to pass the arguments to be positional only. Now keep this in mind, that the thing that the functions or parameters that you're passing is not like the variable number of positional arguments that we have done. Okay, it's not like that. The thing is, sometimes you want to, let's say, to have only positional arguments up to a certain point and only keyword arguments up till some other point. Okay, so if I have to say it in a bit more, like, to make you understand, okay, when you use keyword arguments, you have to make sure that each and every one of those arguments are keyword arguments, right? But at certain times you wouldn't want that. Like, sometimes you don't want to work with a dictionary, sometimes you need to work with a tuple. Okay, so for those cases you need to have a mixture of position and keyword only arguments. So for that reason it was introduced. So the thing is, if you like pass certain arguments, and while calling it, if you use the keyword, you have to use the keyword. Okay, also, to make the code cleaner, we are using this. So what it says is, if you have this function, and let's say you have this variable, okay, now we have, as you can see over here, we have given a space, so there must be something over here. That special character is a backslash, sorry, a forward slash. Yeah, so what it says is, up till here, and let's use this red one. So up till here, these are all position only arguments. You can't use a keyword argument over here. It's strictly mentioning this when you use this. And this one can be anything. It can be a position only argument, it can be a keyword argument, whatever. That's the user choice, but this A and B should be a position argument. position must. Okay, let me write it clean. So position must. Okay, similarly we have this keyword argument, keyword only argument, which says if you have a function and you have variables, so we have to add the parameters to the right, include and this pair asterisk. So let's say let's use var1 var2, sorry. Now over here we have used a forward slash, so the left of this forward slash everything will be a position argument. So if we use an asterisk, everything from the right will be a keyword argument. So kw1, kw2, kw3, we have used 3 keyword arguments over here, and this can be anything. This can be position, this can be keyword, anything. Okay, so what this says is this can be anything, it's the user's choice, but these ones should be keyword arguments. It is strictly because of this asterisk. Okay, yeah, so this is the only thing which was left, and just a quick demo. So position only arguments and keyword only arguments. So def func1, let's say a comma b comma star pos. Okay, instead let's use pos1 and pos2, and over here let's use a comma b. Now print pos1 and pos2, print a comma b, return hi. So yeah, this is one, and we need to call this. So print func1, and it should be strictly position. So let's say 1 comma 2 comma 3 comma 4. We're getting an error over here. Let's see. Okay, so I think it's an error in my part. Let's see. Okay, let's go 5. A equals to 4, b equals to 1. Let's 4, 5. Still, I guess we're getting an error. So I guess if we now, maybe it shouldn't show the error. We have done this, so we have the pos1, we have the pos2. Oh sorry, we are using position only, na? Yeah, So position has this. I forgot. Position has forward slash. So we have this forward slash. Still we are getting this error. So 4,5. Yeah. Now it's done, and yeah, it's working fine. So now if we run this, it showed 4,5 and 3,5. Yeah. What if we give pos2 as 4? It will show an error. So yeah, that's one thing. 7. I don't show any error. Yes. Yeah. Fine. And there's one thing. Okay, we're using a function. Oh, yeah. Second we have is func3, and we'll be using the asterisk for this one. So let's say a comma b, and this should be an asterisk, and then kw2 and kw1, print a comma b and print kw1 kw2 and return hello. So now if we print this, we'll be having func3, and so we need to pass some values to a and b. So 1, 2, 4, 5. So obviously it will throw an error because we are using an asterisk, and it should be keyword only. So kw1 equals to 4 and kw2 equals to 5. Now it should run without any error, and yeah. So yeah, this was all about functions, and I haven't decided what I'll do in my next video. I will think about it. But yeah, if you like this video, then hit the like button, and if you're new to my channel, hit the subscribe button, press the bell icon so you never miss an update, and I will see you next time.